Good afternoon, Ankit. Let's just wait 2 minutes so that everybody can join. Have you guys given a thought to the two compounds which I gave in an answer to find out whether it would be aromatic or not?
Yes.
So, what according to you guys would be aromatic or non-aromatic or anti-aromatic?
Anti-aromatic.
Anti-aromatic. Okay, Ankit is saying anti-aromatic, right? Let's see what Reshma, Sheetal, everybody else has to say on this. I suppose one compound was this. And the other,
Yes, ma'am.
and the other compound was right. These two compounds I gave at the end, and you're saying both are anti-aromatic, right?
Yes, ma'am.
Okay. Let's see what others are also saying. I think everybody is here now. So, as per Ankit, I think if you guys remember last when we stopped, I gave you these two questions to think about whether they will be aromatic, anti-aromatic or non-aromatic, and we were supposed to discuss it together. As per Ankit, both are anti-aromatic. What about others? What do you deduce these structures to be? Aromatic, anti-aromatic or non-aromatic? Sheetal, Reshma, who else do I have? Shanmuri, Shanmuka, Pushkin, anti-aromatic. Sheetal is as well saying anti-aromatic. Okay. So let this be compound A. Okay. So Ankit, you are saying anti-aromatic. Why? First you have to find the structure which will have the delocalization perfectly. So for that, I'll shift this bond to here. So I will get O minus positive, O minus positive. Right? This is the structure I would get.
Yes, ma'am.
So I know this molecule is cyclic. Perfect. Now I know this molecule is planar as well. Now I need to check whether it has conjugated system or not. So conjugated pi, sigma, charge, sigma, pi, sigma, charge, sigma. So that means it is delocalized as well. So these three conditions are fulfilled. Now I need to see whether it follows the Hubble's rule. 4n plus 2 pi electron becomes equals to over here 4 pi. Thus my n becomes equals to, what does my n comes out to be?
Half.
Half. That's why it is anti-aromatic. Perfect. Everybody understood why it is anti-aromatic? Now what about this compound? What happens in this compound? Cyclic, very well I can see. Planar as well. These two conditions are fulfilled already. Fine. Now I need to see how am I going to incorporate the delocalization. So pi, sigma, pi, sigma, the lone pair, then the sigma, then the pi, then the sigma, then the lone pair. So that means the delocalization is complete. I'll be considering both the lone pair. So on this one pair, on this one pair. So that means how much does my pi electron comes out? 1, 2, 3, 4, 5, 6. That means what it would be? 4n plus 2 pi electron. So that means 6 into 2, 12 pi electron. Right? So my n comes out to be 10 upon 4,
2.5.
2.5. That's why it is not following Huckel's rule. This also becomes anti-aromatic. Now I feel that you guys will not have any problem in solving any type of question based on aromaticity. I hope I made you guys perfect in finding out anti-aromatic, aromatic and non-aromatic. Can I assume that?
Yes, ma'am.
Fine. So, today we are going to do the nomenclature. Why does this nomenclature so important? Everybody can see the screen, right? So,
Yes, ma'am.
IUPAC nomenclature. That is what I am going to study today. IUPAC nomenclature. What does IUPAC stand for? International Union of Pure and Applied Chemistry. So, nomenclature means naming of my organic compound. Right, this is what I mean, naming of my organic compound. Why does the name become so important? So, like my name is Sandhya and your name Reshma or Ankit. So we all have individually different names. That is how we are distinguished at the first go. That if I have to refer to someone, so let's say if I have to call up a name in the class, so I'll be referring you by your first name, right? So that's why the names are very important. So in the earlier time, when there was no set rules for naming of these organic compounds, so they were named as per they were derived. So like in the nature, if they are derived from ants, they have been named according to that. And if they are derived from some sand, they were named as per that. Okay, but this become a very tedious job, because I know there are wide range of organic compounds are available in nature. I cannot go just like that, remembering each and everything. So like vinegar. Vinegar composition is acetic acid. Acetic acid is not the nomenclature. It is the common name. It is the common name for the vinegar. Vinegar composition is acetic acid. Similarly, vitamin C, ascorbic acid, or fruits and juices have citric acid, right? These all are organic compounds, but they are named as they are obtained from the nature. Okay, so why did it become very important to name a compound? Because we need a common pathology for everyone to understand, that no one is left behind while naming something in a very systematic manner became a very essential thing in the organic compound, because we are dealing with such varieties of organic compound, right? Right now we are only limited to carbon and hydrogen chain, but when we are going to study biomolecule, wherein we are going to see long chain of them and proteins, so it's going to be a vast, so I need to have proper naming for that. That is how the IUPAC system came into the picture. That is what it is referred as IUPAC nomenclature. By using this, you can even name the complex structures. But for the time being, 11th and 12th, we are not going to go that depth into doing the very tedious or the complex structure. Here we are going to deal as in like the simple molecule, and we are going to study about their rules and everything, and I am sure you guys are very well acquainted with it, right? So this is what I was telling you about. Trivial system, that is wherever they are obtained from, that is how they were named. So like formic acid was obtained from red ants, so they were named as per. Similarly, acetic acid, acetum. of the vinegar. That's why it was referred as acetic acid. So what are the rules for naming? The rules for naming is, first thing first, when it consists of 4 parts. It consists of 4 parts. What are the 4 parts of a name? There should be a prefix, that is, wherever there are different types of substituent groups which are present. What are the generally prefixes which are available? The halo group. Halo groups are present as your prefix. So, if at all a fluorine group is present, it is referred by the name fluoro, then Cl, fluoro, bromo, iodo. So, what did I just do? I have fluorine. Instead of RINE, I just added INE, I removed it and I added O to it. Fluoro, chloro, bromo, iodo. That is clear. NO2, nitro, CH3. CH3 means methyl group, C2H5 ethyl group, or if you go further, you can even have C4 and H9. I can have, that is butyl group. Okay, so I can have these many groups as prefix, which are generally going to be useful for you. Nothing beyond this will be coming to you. So first part of the IUPAC nomenclature is the identifying the prefix. After that, word root. Word root means that is finding out the longest chain possible in that organic compound. And after you find that longest chain, what you need to see? You need to see, where is it? Here. Word root. It indicates the number of carbon atom in the longest possible chain. So if at all a carbon has 4 as your longest chain, then the word root is but. If it is 5, then it is pent. If it is 6, then it is hex. So in the case of alkane, it becomes really simple. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. So if I have a single chain of CH and no branching in it, that is the alkane molecule, then I just have to add ane from the word root. No substituent group present, nothing at all, right? So I need to determine the longest chain among the existing group in order to find out the word root. Is it clear so far?
Yes, ma'am.
Yes. So, what is the next thing which I need to find out? I need to find out primary suffix and secondary suffix. Now, what does this mean? Can anyone tell me what does a primary suffix means and what is a secondary suffix? Have you heard about these terms? Suffix. So prefix is something which is going to come before the word root. Suffix is something which is going to come after the word root. So primary, secondary. What does that mean? Anybody? Ankit, what about you? Reshma, Shanmuga, anybody who can tell me what is a primary suffix and what is a secondary suffix?
Ma'am, secondary suffix like the main functional group.
Yes, secondary suffix is the main functional group which is present in the molecule. Right? Then what is primary suffix? If secondary suffix is this, then what is primary suffix? What could be the primary suffix?
And if another functional group is present.
Yes. So there can be a possibility of two functional group in the same molecule. So the one which is of the lower priority, that functional group will be considered as primary suffix. Okay? Lower priority functional group. Clear? So if I see it in detail, what would it be? So primary suffix is generally ane, that is your alkane, which is a single bond. On the contrary, ene, which is alkene, which is a double bond, and ine, that is alkyne, which is a triple bond. So these three, you will never be placing it as a prefix. These three can never come as prefix. That's why they are grouped as primary suffix. Let it be, I have a double bond with an OH group. Double bond with an OH group. When I am considering the name of that compound, the double bond being lower priority than the hydroxyl group, but it will not come as prefix ever. That is why my word structure is equal to So this is how my word structure is equal to. I need to find out IUPAC name. So I need to first write the prefixes, then word root, then primary suffix, and then secondary suffix. This is how I am going to write name of each and every compound present in the organic chemistry. So what it will consist of? It will consist of prefixes, whatever the number of prefixes it contains. That will be first written, followed by the word root, then the primary suffix, and then your secondary suffix. Clear? Now let's see what all groups, functional groups, can actually come as prefix as well as suffix. So I mentioned that alkane, alkene and alkyne cannot come as prefix. Now let's see what all can actually come. So can you see? Is it clear or is it hazy? I feel it's little hazy, I suppose. Or is it clear? The slide?
Ma'am, yes, it is clear.
It is clear? Okay, fine. So now you can see IUPAC suffix which is being mentioned and IUPAC prefix is mentioned. So now you can see which groups can actually act as both suffix and prefix. So let's say if I have a functional group which is present, two different functional groups, carboxylic acid as well as an alcohol. I know carboxylic acid will prefer and it will come as a with the word root. So then where will this hydroxy group will go? Hydroxy group will come as prefix. So that is what we are trying to establish. What is actually the name which I am going to write. So if at all it's an alkene, alkynes, then all I have to do is write ene and ine. Ene or ine at the end of the word root. That is clear. Halides, I was clear, there is no suffix for it. Halo, fluoro, bromo, iodo and fluoro, right? That is clear. Alcohols. Alcohol mean presence of an OH group. OH group in the case of a suffix. So let's say if I have been given CH3OH. So the word root is meth, that's because it contains one carbon, followed by an OH, so it becomes methanol. So I replace methane, had it been methane CH4, so I replaced this E with all. So I am replacing E with all. Is it clear? What am I replacing? I am replacing E with an ol. Clear? So proceeding further, so if at all this OH group has to be in a prefix form, then it will come as hydroxy. So let's say in a compound, if I have CH3, CH, OH, COOH. So in this case, it will come as prefix 1, 2, 3. At the second position, I have hydroxy group, 2-hydroxy propanoic acid. Then it is coming as a prefix. So which functional group can come as prefix as well? Alcohols can come as a prefix as well. Clear? Fine. So proceeding further, aldehyde. In the case of aldehyde, E is replaced by al in the case of suffix. And if it has to come as a prefix, then it will be represented as oxo. Similarly for ketones, E will be replaced by one. So that means methanol is not, ethanol is also not, propanone or butanone, right? And when prefix, then it is as oxo. Nitrile group, nitrile, that means C triple bond N. So how will it come as? When I have to write it as a prefix, it's a cyano group. So 2-cyano, 5-cyano, wherever the position is. Or else, when it is in suffix, so let's try to understand it with an example. Let's say if I have been given CH3, CH2, Cn. Everybody can see this example, CH3, CH2, Cn. How many number carbons are present over here in this molecule? What will be the word root? 3. Everyone is agreeing that the carbon of the nitrile will also be considered, right? You cannot miss out on that. So when it has 3, so then this name becomes propane nitrile. So in this case, the E is not replaced. It is written completely and followed by a nitrile. Is it clear? Everywhere else, in the case of alcohol, aldehyde, ketones, I was replacing E with something, the last letter E with something. But in the case of nitrile, what I am doing, I am not replacing it, I am writing it completely followed by nitrile. Clear? Proceeding further, then I have another functional group, ethers. So you can see ether also does not exist in a suffix form. It does not exist as a suffix form. What is it existing as? Prefix only. So it is represented as alkoxy. That means methoxy, ethoxy, butoxy, propoxy. Oxy is the group. So word root as in you need to find it as a prefix. So let's try to understand it with an example. Let's say I have given CH3O C2H5. That is the ether group, that the oxygen is clamped between the two alkyl chain. That is ether group. So when I have to name this, I will select prefix as the smallest and suffix as the longest chain. So the longest chain is the 2 carbon. So that means that will come as my word root. And this is the prefix. So that means this name becomes methoxy ethane. What does it become out? Methoxy ethane. Clear?
Yes, ma'am.
Carboxylic acid, it will come as oic acid. So what are we doing? We are replacing E with total oic acid. Right? Similarly, if I had to present this as prefix, which is a very rare case, understand carboxylic acid is the highest priority functional group. It will never be coming as a prefix. But if in 1% case, it does come, then I will represent it as carboxy. Okay. Next, carboxylate ion. Ion means that is an H plus ion has been dissociated from the carboxylic group. So if I have benzoic acid, that is benzene ring with COOH group. So this is my benzoic acid. So when I have this benzoic acid, if this H group is removed, then it becomes benzoate. That is, I have replaced OIC with O8. Similarly, propanoic acid, propanoate. Butanoic acid, butanoate. Clear? Next, esters. They are also very important. Can anyone tell me what is ester found in very commonly in nature? Esters.
Toffee.
Where?
Toffees, candies.
Toffees and candies. I wouldn't say that. Toffees and candies have sugar in it, and sugars are glucose.
And flowers.
Yes. So they are sweet smelling. Esters are generally very sweet smelling. And the most common place where you can actually find esters is shampoos, soap, perfumes, which you must be using it very regularly, right? So esters are the compositions of those. They are known for their fruity and a flowery smell of them, and that is why they are widely used in the perfume industry. Okay? So in the case of ester, what is the functional group? COOR. That means the H of the carboxylic acid has been replaced by an alkyl chain. So what happens in this? Similarly, O8, that is what it is. So if I have to see it by an example, let me write it here. If I have to explain it by an example, so I have CH3, COO, CH3. If I have been given a ester like this, so what I can see, the COO, so remember the bonding always is like this, C double bond O with O, which is present as like this, and this is how the bonding. So which will be the word root? So word root would be carbon number 1, carbon number 2. So that means 2 carbon, and this will be treated as methoxy ethanoate. Methoxy ethanoate. So how does it methoxy ethanoate? This is coming as prefix, and the word root is eth followed by O8 because the ester group is present. Clear? So we are left with 2 more functional groups which we are going to study, amines and amides. How are they different? Amines means NH2 group present. So in this case, methane, methane, amine. E is replaced by amine. Propan, amine. E is replaced by amine. Butan, amine. Clear? So E is getting replaced by amine. And if it had to come as a prefix, then it will come as amino. It will come as amino. On the contrary, amides, in the case of amides, it is the OH group of the carboxylic acid has been replaced by an NH2 group. OH group is replaced by NH2 group. So then this becomes amide. So if I have been given one compound, let's say CH3, CH2, CONH2. Then this compound name, what would be the compound name for this? CH3CONH2, this one. CH3, CH2, CO, NH2. What would be the name of this compound will be? Anyone?
One aminopropanone.
Propanone. No. So, now where did you go wrong? Let's see. So, Reshma has written methanamide. Okay, Reshma and Ankit will deal with both of your answers and we'll see what is it exactly. So, let me just...
And ethanamide.
Ethanamide, okay. So, wait, let me just go to a plain slide wherein I can write. Do I have a plain slide in this? Okay, let me just quickly go to this one. So I gave you CH3, CH2, CO, NH2. And first answer given by Ankit was, what was it?
Ethanamide.
Ethanamide, okay. And Reshma, you gave an answer, methanamide. Anybody else who can give me an answer on this? So both are wrong. How? 1, 2, 3. You forgot to calculate the carbon which is present at the CONH2. And Reshma, you forgot to calculate the 2 more carbon which were present. So, what should be the name? The name should be propanamide. Why? Because the word root which comes out is to be prop, and then the functional group which is present is the amide group. That's why it will be propanamide. Clear?
Yeah.
So let's say I have given you how will you name this compound? So there are 2 different functional groups which are present, and first thing first, what you have to do, you need to find the longest parent word root. What will be the first longest parent root? Word root.
Ma'am, from CN to CONH2.
So you're saying 1, 2, 3 and 4. Right? This is what you're saying?
No, ma'am.
Hmm.
CN is 1 and CONH2 is 4.
Okay. So you are saying, sorry. You are saying this is 1. This is 2, this is 3 and this is 4. Okay. Now okay, shall I give you a simple example before we proceed to this, because this has become very common. Let me give you this instead of that one, because that will consider the period, the level of the whatever is the functional group priority, which I haven't taught yet. So if I give you this, then what would be the answer? What would be the word root?
2-chloro-butanamide.
Okay, Ankit, from where did you number it? You numbered
Ma'am,
it?
from CH3.
Okay. Functional group should always get the first priority. 1, 2, 3 and 4. Okay, the functional group will get the highest priority. So when I've given the functional group the highest priority, this becomes 3-chloro-butanamide. Anybody has a doubt in this? Why this has to be 3-chloro, not 2-chloro? Ankit, you are clear? This is wrong and this is right.
Yes, ma'am.
Everybody else is also clear? So let's see what are the rules followed for naming the organic compound. While naming the organic compound, the rules followed are so we were here. Fine. So the rule followed is, so first example which has been given here, can everybody see what is the example which has been given? The example given over here is CH3 CH CH2OH, and there is a branching at number 2. So see how they have numbered it. The functional group, so they have identified the prefix first. What is the prefix? The methyl group which is present. Here is the methyl group which is present. Primary suffix is an ane, so that because it's an alkane, so that's what he's saying. Primary suffix is alkane. What is the secondary suffix? Secondary suffix is the functional group which is present, which is an alcohol group. So which is ol. So the IUPAC name for this comes out to be 2-methyl-1-propanol. I'll be defining the number of the functional group where it is present. So how am I writing it? What am I writing it? 2 represents the position of the methyl group, followed by a dash, then a methyl, then dash 1 which represents the functional group placement, which carbon it is attached to, and then your propanol, which is the word root, which is prop, and propane, and E has been replaced with ol. Is it clear?
Yes, ma'am.
So first thing is clear. So this is how we start naming our. So what are the IUPAC rules for naming the organic compound? First thing first, I need to determine the longest chain group. So that is, I need to select the chain in such a manner that the number of carbon present in that chain is the longest. So let's try seeing these two examples. One is wrong, one is correct. You can very well see what it is. So first case, I have numbered it as a straight chain like this. Okay, 1, 2, 3, 4, 5, which gives me 5 is the maximum number which is contained in the parent chain. Okay, whereas when I start numbering from here, 1, 2, 3, 4, 5, 6, I see I get 6 as the parent chain, which is higher in number than 5. That's why this method becomes the correct way of numbering this. Now you can ask me, ma'am, why didn't I numbered it like this? 1, 2, 3, 4, 5 and 6. Does anybody has this question? That why am I not numbering from here? Why am I numbering from the below? So I need to ensure while numbering the prefix which I am going to introduce is going to have the lowest number. So if I number it from this side, I see the prefix which is present, which is a methyl group, gets a 4 number. Whereas when I number it from here, it gets a 3 number. 3 methyl, 4 methyl. Which is smaller? 3 methyl is smaller. So my name becomes 3 methyl hexane, not 4 methyl hexane. Is it clear? 4 methyl hexane would be wrong again. This is wrong. Finding just carbon chain 5. This is also wrong. What is the correct method? Finding that it has 6 carbon and the substituent is present at the 3rd carbon position. Clear? So what is the first rule? Finding, identifying the longest chain. Okay? After I identify my longest chain, what is the second rule? Lowest number rule. Like just we did it. Lowest. The carbon chain selected is numbered from end nearest to the side chain or substituent. Nearest to the side chain or the substituent, so as to give the lowest number to the carbon carrying the side chain. So I have it over here, 2 examples if you see it. So there are 2 ways of numbering it. One from left to right, another from right to left. Right? You can very well see it. In the case when I number it from left to right, I get 2 methyl. Whereas when I get number it from right to left, then I get 3 methyl. Which one is the lowest number?
2.
2 methyl is the lowest number. So 2 methyl butane becomes the correct name for this compound rather than 3 methyl butane, which is a wrong method to name this. So what all 2 rules I studied? First rule, identifying the longest chain. Second rule, the substituent, the prefixes which I am going to have should have the lowest number. Clear?
Yes, ma'am.
Let's see the third rule. Third rule is I can have more than one prefix. So right now, still now, whatever I was teaching you about one prefix. Right? I can have multiple prefixes. So that is what my IUPAC normal prefixes. I have ES at the bracket. So what if I have 2? So let's see what happens. In this case, if you see, if more than one group is attached to the carbon chain, these groups should be arranged alphabetically. First thing first, they should be arranged alphabetically. Fine. When 2 or more identical substituents are present, so let's say I do not have different, so methyl group is present at 2 different places, 2 methyl groups are present, then the prefixes like di, tri, tetra, so di means 2, tri means 3, tetra means 4, penta means 5, similar like the word root. So that will be added just before the, so like if I have 2 places dimethyl, so let's say second and the third position has 2 methyl groups, so I'll write position of the 2, bracket, comma, with 3, then dash, dimethyl, 2, 3, dimethyl. So I'll define the position of both the methyl group, followed by how many numbers of methyl groups are present, and then followed by the word root. So let's see by an example. So example over here, if you see it, so it has been numbered from left to right, and this side it is numbered from, both the sides is numbered from left to right. So when I see it, I say there are 2 methodology, and in which one is right and one is wrong. Now let's see what it is. So when I am numbering from here, I can see the methyl group is coming at the second position, and fourth position I am getting an ethyl group. I said that the group should be arranged alphabetically. So that means 2 methyl, my M in the alphabet comes way after your E. That's why this became the wrong method. What should be the method? 4-ethyl, 2-methyl hexane. So here you see the number does not signify over here. Number doesn't really matter. What does it matter? The ethyl group, propyl group or butyl group, whatever is present, should be arranged alphabetically. So let's say if I have methyl group in one and propyl group and butyl group. These three groups are present in any of the alphabetical arrangement would be first to this, second this, and then third this, because B, then M, after M, N, O, P comes. So that's why propyl gets the order of 3 instead of 2. Clear?
Ma'am, in this example, 4-ethyl, ma'am, if at second position one more methyl comes, then it will become dimethyl. So ma'am, D, then dimethyl will come first.
No. Then to the substituent, D will not be considered. What will be considered? Methyl M. Prefix alphabet will be considered, not the prefix preceding this di, tri, tetra. It doesn't really matter. My alphabetical order is based on the prefix, not on the di, tri, tetra, penta or something. So
yes, ma'am.
the example which you took, let me just take that one particular example which you are trying to tell me. So what you are trying to tell me is you are replacing here, right? This H is being replaced by a CH3, right? That is what you are saying. So when I have to name this compound, this again will become 4-ethyl. 4-ethyl. After that, 2, 2 dash dimethyl hexane. So there you see, I defined the position of the 2-methyl group via a comma and dash at the end, and only the first letter will be capital. Remember, generally students do this mistake also. Even if you see over here, only the first letter is capital, irrespective if it follows E. So this will never be capital, or hexane H will never be capital. It will all be slow going in cursive. Clear? This was about arrangement of prefix. So here you see over here, what is it written? If two different groups are present and are located at equivalent position. So there could be a position. So here in the earlier case, they were very different than each other. So there wasn't an equivalent position. I numbered it. When they are, so like if I number it from here or here, so 1, 2, 3, 4, 5, 6. So if I see over here, 4, 3, 3, 4. But the only difference is in one place there is an ethyl group, in one place there is a methyl group. In that case, what happens is, again the alphabetical order followed. So ethyl comes first in alphabet, so that gets third position, and the methyl group gets fourth position, instead of 4 given to the ethyl and 3 given to the methyl. So it is following the alphabetical order in the case of the lowest position to be assigned. So this becomes 3-ethyl 4-methyl hexane. Clear?
Yes, ma'am.
The next very important rule is the lowest number to the functional group. the functional group should get the lowest number. So like the other time when you did, ma'am, it should be numbered from the other side. That is wrong. The lowest number should be given to the functional group. So here you can see the OH group is present in between, right? It is not at the end. So I need to see from where shall I number it, it will get the lowest number. So if I am numbering from left to right, the number assigned is 4, right, to the functional group. Everyone is able to see that. Whereas if I am numbering from right to left, the functional group gets the 2 number. So 2 is smaller. 2 is smaller. So everyone is clear. 2 will be given. Now let's see how the name is being written. Name. So I know at the 4 position I have 2 methyl group. So that means 4,4 dimethyl. Up to this part it is clear. Now they have mentioned the position inside the name. Earlier when we were doing that, we were mentioning it outside the name. Were we doing that? If you guys remember, 1 pentanol we wrote it in the other example. Here I am writing it inside. Both of them are correct. You will not lose mark for writing it. So if I write this name 4,4 dimethyl 2 pentanol. If I write this name, this is also correct, provided I mention the number correctly. I can mention it like this as well, pentan 2-ol as well. But following this terminology is more convenient because very simple compounds are not given anyways. Some complex compounds are given. When some complex compounds are given, I need to number them. So more than 2 functional group will be there, a double bond will be there. Then mentioning the position of it just within the name becomes simpler in comparison to outside. Because you have primary suffix as well as secondary suffix. If you had only one secondary suffix, then it's fine. Or just one primary suffix. When the case arrives when you have primary as well as secondary suffix together in a name, then numbering inside becomes more convenient. We'll see the example, then it will become more clear. But as of now, if you follow this, I'll advise you to follow this, because if at all only one functional group is present, then it's fine. Follow either of them. But if there are multiple, then it would be the convenient one. This will be the preferred one. Clear? Anyone has a doubt? I am not getting a very good response. Is it too much, or I think you have done this, so this is just like a revision for you guys, right? But it's just that we are going in detail so that we do not miss out any points, right? Because while doing the organic chemistry, what is the first and foremost thing? Knowing the name of that particular compound. Clear? So we have reached the fifth rule which is to be followed. What is the fifth rule? Presence of identical group. So that means the functional groups or the prefixes, if they are too many, so like too many OH are present in one. So you heard about glycerol, glycerine, glycerol. It has 3 OH groups. What will I do? How will I name that? And if at all it has 2 Cl group, then I got stuck. How will I name this? Then in order to name this, so see what it's being done. In an organic molecule has more than one functional group, the prefixes like di, tri, tetra is used. So similarly, in the case of methyl, as we use it, dimethyl, trimethyl. Similarly, I'll be using diols, dinitrile, dioxo. I'll be using something like this. So what it will be? So let's say if I have been given this as an example, where 4 number carbons are there, in which all 3 of them has OH group attached to it. OH group attached to it. Now there comes a catch. See over here, what is the catch? If you see, they have written the whole parent name, butane, not butan. We replaced E and then replaced it with an ol, right? Remember? That is what the idea was when I presented it. E has to be replaced by ol, but here I have written E. So, why E has been written if anything followed over here is not vowel? A, E, I, O and U. If O was there, then I would have written but. Otherwise, now here T is there. T is not a vowel. So I will write the whole word. So it became butane 1, 2, 3 triol. Clear? Or too much to understand on one go?
Yeah, ma'am.
Clear? What about others? Fine. So that means everywhere else, so own, O8 or else al. So everywhere there is a vowel, O, most commonly O or A. So if the vowel is not present, so here in the case tri is present, then you will write the whole of your word root, butane. Similarly over here you see 2 nitrile groups are present, and 2 nitrile groups are present at 1, 2, 3, 4, 1 and 4 position. So I'll write it as butane 1,4-dinitrile. Clear?
Yes, ma'am.
Now comes the main thing. When I have to name the unsaturated hydrocarbon, how will I name the unsaturated hydrocarbon? I have seen unsaturated. So butane, that is saturated hydrocarbon. If at all a double bond is present, and butane can have double bond either at 2,3 or 3,2. So in this case, the double bond is present at the first, second carbon. So I need to specify the number. At which that double bond is present. So you can say, ma'am, why not it is 2? Why it is 1? You can have this question, right? Why not it is but 2-ene? Because as the double bond is between 1 and 2. You can have this question for me, right? Why do you think that is not the answer? Why but 1-ene is the answer?
Ma'am, because it is starting from 1.
Yes, the bond is getting started and it is made like this. So if I am going to consider bond to be like that, if I am going to consider that the second position has the bond. So if I am going to define it like this, then I will never be able to explain that whether it is the second carbon is having bond with the third one or the first one. So in order to have that ambiguity differently, I am already defining it in such a way that it has one carbon which is associated, the first carbon to be associated. So that's why it becomes but 1-ene. Now you can ask me, ma'am, why didn't I just replace butane E with ene? No. Because when I write butene, it becomes but-ene. All of the ane is being replaced by ene. So that is why it will be but 1-ene. Clear?
Yes, ma'am.
Similarly, in the B example, the alkyne is present. The specification of the alkyne functional group is at second position. Right? When the alkyne is present at the second position and the alkyne is represented by ine, so it becomes but 2-ine. So far it is clear. Now, Let's see a case where there are two double bond which is present. When there is a two double bond present, can you see what is happening? I need to define the position of both the double bond, where it is situated, and the numbering will start from the right to left, not from left to right. This will be wrong. That you have understood. The lowest number should be given to the functional group. So the primary suffix will get the lowest number, so that is 1 and 3. The position of the double bond is clear. Now comes number of carbon, pent. So that means the word root is pent. So now again here you can see it is not a vowel. It is not a vowel. D is not a vowel. So that is why whole penta is written over here. Even you can write pentane 1,3-diene. So in this case I can even write pentane 1,3-diene. Clear? So there should be an order for the functional group. I said the functional group should be numbered in such a way that there is an order. What is the order? So this is the order for the functional group. So here it is being mentioned all the functional group. So starting from sulfonic acid gets the first priority. If at all any organic compound which has a sulfonic group attached to it will get the first priority, followed by carboxylic acid, ester, acyl chloride, amide, nitride, aldehyde, carbonyl, hydroxy, amine, double bond, triple bond, so this is your ether group, halo group, nitro group and alkyl group. This is the priority order and you are supposed to remember this. Very important. Clear? Now let's try to solve some question in order to be certain which priority to be given to which one. So now, see, this is the molecule which is being given to me. In this molecule, you can see there are two functional groups. One is carboxylic acid. One is carboxylic acid. And another one is aldehyde group. Right. So the first priority, numbering will start from the first priority. So this is my first priority, this is my second priority. So numbering starts from 1, 2, 3, 4 and 5. This should be the total carbon chain, but I am going to consider this group as prefix, not as a part of the chain. So that's why they haven't numbered this. So what is the word root comes out to be? But. But is your word group, right? So 4-formyl. Formyl means this group. Formic acid is formaldehyde is HCHO, right? If this H has been replaced, that means CHO group. This is your formaldehyde. And when I try to find out the prefix for it, then it will become formyl. So 4-formyl butanoic acid. Anybody has a doubt in naming of this compound?
No, ma'am.
No. Fine. So I can have cyclic type of a compounds as well, in which a cyclic ring is present. How do I name this? I just add cyclo to the alicyclic. So if at all it would have been a straight chain, whatever the name comes out, I'll just add cyclo to it in order to define what is the cyclic ring which is present. So if I see over here, 1, 2, 3, 4, 5, 6. So 6 carbons, and that means hex, right? Hex is my word root. So that means hexane, as it does not have any substituent group present. So it becomes cyclohexane. Clear? Just adding cyclo to it. Similarly, if I have a second example when a double bond is present and a nitro group. So the numbering will start from the double bond because double bond is higher priority than the nitro group. I can see it from that table. So when I see this 1, 2, 3, 4, 5, 6. So 6 is the hex is your parent name. So when hex is your parent name, 3 nitro. At third position I have a nitro group. So 3 nitro, cyclo because it's a cyclic ring which is hexene. So now you can see they have not mentioned the number of the double bond. That is where it is situated. Is it a right thing to do or is it a wrong thing to do? What according to you, do you feel that not mentioning the double bond position, is it right or is it wrong?
Ma'am, it is right because it is the first position.
Yes. So if at all no position has been mentioned, that means I am going to assume it's the first position. That is why in this case it doesn't matter. What if I gave you NO2 Cl with the double bond here? How will you name this compound? This is your example. How will you name this compound? Let's say I have a double bond here. Can I get the name of this?
Ma'am, 1 chloro, 3 nitro, hex 1, 4 diene.
Okay, you're almost correct. So 1, 2, 3, 4, 5, 6. This is how you numbered it. That is correct. Where did you go wrong? So you said 1 chloro, right? 1 chloro. You followed the alphabetical order as well. 1 chloro, 3 nitro, which is also correct. Where did you go wrong? In here. So it would be hexane 1,4-diene because the vowel is not followed. So I'll be writing it completely. Had it been only one single bond, then the vowel would have been there, then you would have written hexene. But here the vowel is not there, so you write the whole word root, hexane 1,4-diene. Everyone is clear? So 1 chloro, 3 nitro, hexane 1,4-diene. Reshma, you forgot to mention the dashes. We are supposed to mention these dashes are very important, otherwise the answer becomes wrong. It's just like Reshma has an importance of an A at the end, otherwise it will become Resham. So similarly, these dashes are as important as your A in your name. Okay?
Yes, ma'am.
Fine. C part. So what can you see over here? There are two different types of substituent group which is present, and I need to number it. So why did they number it like this? 1, 2, 3, 4, 5, 6. Not the other way around. Here 1, 2, 3, 4, 5, 6. Why did they number it the other way around? First thing. Why did they number it like that? Alphabetical rule.
1 comes before P.
Yes. So this is your propyl group, which is P. This is your methyl group, which is M. Alphabetical order to be followed. Yes, Shanmuga. So that means 1-methyl 3-propyl cyclohexane. Clear? This was about cyclic compound. Aromatic compounds. So I am supposed to name aromatic compounds as well. So there can be groups present on the benzene ring. I know this is referred as benzene. Right? Further to this, when there are groups present on it, how will I number it and name it? That's my task. So when I see over here, there are 2 nitro group and 1 chloro. Chloro is preferred or nitro is preferred? Which group is preferred more? Chloro or nitro?
Chloro.
Chloro is preferred, that is halo group is more preferred. So I'll start numbering from here and I will go clockwise direction, not anti-clockwise. Why is that? I will go clockwise direction. I'm going this way. So this is my clockwise direction, not the anti-clockwise direction. Why is that? Why is that is not happening? Why is that not happening?
Last bond will come at 5.
Yes. So if I number it this way, so let me just change the color of the pen. So when I am going to number it 1, 2, 3, 4, 5 and 6. Right? So when I count the number wherever the substituent are present. So the red one, 1 plus 4 plus 6. This is the total. And whereas when I count the number of the white ones, then it is 1 plus 2 plus 4. What is the sum comes out to be? 1 plus 4 plus 6 is 11 and 1 plus 2 plus 4 is 7. So here comes introduction of the new rule, lowest locant sum. So what is this? This rule says the groups which are present, if I am going to add it, I should receive the lowest number. Lowest locant sum. That's why I will not be numbering it with the red marking. I'll be doing the white numbers only. So when I do that, what will happen? 1 chloro, 2 4 dinitro. At 2 position nitro is present, at the second and the fourth I specified it with the dash dinitro followed by a benzene. Clear? Similarly, if I see the B example over here. Now, in this B example also there could be a numbering which is possible. 1, 2, 3, 4, 5, 6. In that also, if you sum that 1, 4, 6, it's going to be 11. 1, 2, 4, it's going to be 7. Lowest locant sum is followed. That is why 4-ethyl 2-methyl aniline. Now here you say aniline, right? Aniline is the ring with the NH2 group, will be referred as aniline. So then you have many more rings like this which has a one particular name. So like if you have OH group attached to a benzene ring, it's referred as phenol. If you have CHO group attached with a benzene ring, then it is benzaldehyde. Similarly, if you have OCH3 group attached to the benzene ring, then it is anisole, and you're supposed to remember all this. Clear? Now, Your task is to name all these 4 compounds. And now who can tell me, this is your exercise based on the whatever we have studied so far. So 4 compounds are given, A, B, C and D. Let's go one by one. A part, how will I name this?
Butane.
So Ankit is saying but to E. Everybody is agreeing with him? Yes, Reshma is also agreeing. So 1, 2, 3, 4. At the second position I have a double bond, that's why but to E. B part. What will happen to the B part?
Two methyl, 3 methyl.
Think again.
Butane, 1, 3.
Ankit, think again. 2 methyl, 3 methyl. Both the groups are same. So what do we do at that time?
Dimethyl.
Yes, dimethyl.
2,3 dimethyl. Bute. 1,3 diene.
Dimethyl. And then, what did you say? But?
1,3 diene.
Butane. Because the vowel is not followed. That's why dibutane. So 1, 2, 3, 4 and 4. So there are 5 carbons. How come you got only 4? 1, 2, 3, 4. Acha, okay, I written it wrong. Sorry. My bad. Sorry. So this becomes 4. Clear? C part. What happens?
2,2-dimethyl butane.
2,2-dimethyl butane. Everybody is agreeing? 1, 2, 3, 4. So it becomes 2,2-dimethyl butane. What about the last part, D part?
Three diethyl pentane.
Okay. Everyone, what about others? I want participation from all of you. So what Ankit is saying is, I am numbering like this, 1, 2, 3, 4 and 5. And at third position I see an ethyl group, another ethyl group. So that's why my answer becomes 3,3-diethyl. 3,3-diethyl. What will be the next? Pentane. Clear?
Yes, ma'am.
So that means we are done with the, so let's try what will be the IUPAC name of neopentane. What does neopentane means?
Ma'am, 1 carbon and that all 4 hydrogens are substituted by 4 methyl groups.
That is neo. Everybody is agreeing with that? Neopentane. Anybody else who thinks that is not neopentane? Can you say that again, Ankit, for the class? So I have a
And 1
carbon.
carbon
Yes.
and 4 methyl group attached.
4 methyl group attached to it. Everybody agreeing with this? Option
Yes,
D.
ma'am.
Option D. Everyone saying option D. So option D is the answer then.
Yes, ma'am.
How do I number it? 1, 2, 3. So at second position I have 2 methyl group. So 2,2-dimethyl propane. What about here? Now I see another different type of a linkage over here. What kind of linkage is referred as this? This is referred as epoxy linkage. This is referred as epoxy linkage. So this epoxy linkage, that means what will be the answer?
First.
1, 2, epoxy propane. Everybody agreeing? Yes. 1, 2, epoxy propane. Let's do 2 more examples for today and then rest we'll practice it in the next class. So there you go. So the first one example which is given is IUPAC name of, I hope it's visible, CH3CO CH CH3 twice. What will be the answer for this? So I have been given CH3 C double bond O CH with one CH3 here, another CH3 here. This is the open structure for this. When I see the open structure, when I number it, how will it look like? Where will I start the numbering from? I'll start the numbering from left to right or right to left?
From left to right.
Left.
Right to left.
Right to left, left to right.
Left to right.
CH3 C double bond O.
Yes, 1. So this becomes 1, 2, 3 and 4. So when this is your 1, 2, 3, 4, that means at second position I have own group and at third position I have a methyl group, right? So this becomes 3 methyl butanone, right? That will be the answer, which is third option. What about the next one? The cycloring one. What would be the cycloring one? Where would you start numbering from? How? Third. So
Third one.
Ankit is also saying third. Shanmuka is also saying third. Reshma is saying option 1. Avni, what about you? So when I start numbering from here, my functional group should get the first number followed by the substituents which are present. So that means this is the order in which I'll be numbering it. When I've numbered it in this way, that means 3,3-dimethyl. That's the first thing I see over here. 3,3-dimethyl. After that, what do I see? I see a cyclohexane ring in which an OH group is attached. So that means cyclohexanol or hexanol, whatever is, or hexanol or 1-hexanol, cyclo. So I'll be mentioning the number over here, 1-hexanol, right? So that's why third is my right answer. Clear?